Right now, somewhere near you, something is breathing. It pulls oxygen from the air, it consumes fuel to keep going, it grows when conditions are right and shrinks when they are not. It produces waste, it responds to its environment. It even reproduces, sending sparks ahead of itself to start new versions of itself in new places. That thing is fire, and the uncomfortable question is this: why exactly isn't fire alive? You probably learned the definition of life in school. A living thing must take an energy. It must grow. It must respond to its environment. It must reproduce. Check those boxes and you have life. Miss too many and you have chemistry. Fire checks almost every single box. Strike a match and watch what happens. The flame pulls in oxygen the same way your lungs do. It consumes fuel, wood, gas, wax, the same way your cells consume glucose. It releases carbon dioxide as a byproduct, exactly the way you exhale. It grows when you feed it and collapses when you starve it. Touch it with new wood and it spreads. It has responded to a stimulus and extended itself into new territory. So what exactly is the problem? The standard answer: fire has no cells, no DNA, it cannot evolve. It is a chemical reaction, rapid oxidation, the same basic process that makes iron rust, just fast enough to produce light and heat. But every one of those objections is more fragile than it looks. Start with cells. Cells are the basic unit of life as it evolved on Earth. But the requirement for cells is not a law of the universe. When biologists look for life on other worlds, they do not require cells. They look for chemistry that organizes itself, consumes energy, and persists over time. By that standard, fire is doing something very interesting. Because then there is DNA. Fire has no genetic material. A new flame lit from an old one inherits nothing from its parent. Fair enough? But consider, viruses were thrown out of the tree of life for exactly this reason. They have no metabolism of their own. For most of the 20th century, biologists said viruses were not alive. Researchers like Carl Woese and Lynn Margulis pushed back on the rigid definition of life, and the conversation got complicated. Whether viruses are alive is still officially unresolved. The definition of life is one of the most argued over questions in all of biology. In 1994, NASA assembled a team to define life for Mars missions. Their answer: life is a self-sustaining chemical system capable of Darwinian evolution. Self-sustaining: fire sustains itself as long as it has fuel. Chemical system: fire is absolutely a chemical system, capable of Darwinian evolution. This is the one fire cannot clear. It does not pass on heritable variation across generations. A fire today is chemically identical to a fire from 100 million years ago. No lineage, no ancestry, no improvement. That gap is why biologists do not call fire alive. But Stuart Kauffman, a theoretical biologist at the Santa Fe Institute, has spent his career studying autocatalytic sets, systems of chemical reactions that catalyze themselves, forming self-reinforcing loops that look like the earliest chemistry of life. Fire is an autocatalytic reaction. The heat it produces causes more fuel to oxidize, which produces more heat. It feeds itself. It maintains itself. It is a self-sustaining loop of chemistry that persists by consuming its environment. Kauffman does not call fire alive, but he argues that life and non-life exist on a continuum, not on opposite sides of a hard wall. Consider what happened 3.7 billion years ago. The first self-replicating molecules appeared in the warm chemistry of early Earth. No cells, no nucleus, just chemistry that happened to copy itself. A biologist watching that first moment might have said, "That is just a reaction, that is not life." They would have been wrong. The philosopher of science Carol Cleland at the University of Colorado argues that our definition of life is deeply Earth-centric. We built it by looking at life we already had, then declared anything matching that pattern was alive. That is circular reasoning. We are using life to define life. If fire appeared on another planet first, a chemical system that consumed atmospheric gases, grew in response to fuel, reproduced by contact, and died when conditions turned hostile, the data would be taken very seriously. So here is the honest answer. Fire breathes, fire eats, fire grows, Fire reproduces, fire responds, fire dies. The one thing fire does not do is evolve. No generations, no memory, no inheritance, no improvement. That single missing step is the wall between fire and life, but it is a narrower wall than you thought. For hundreds of thousands of years, your ancestors sat around fire. Right now, somewhere near you, something is breathing. And after everything you just learned, you are still not entirely sure what it is.